Welcome to VJD Academy. This is Anil Kumar, Faculty of Digital Electronics. In the previous lecture, we have seen 1-bit comparator, and now let us try to understand 2-bit comparator. Sir, comparator is a combinational circuit and it is having defined inputs and defined outputs, and we can say that combinational circuit does not have any kind of memory, and it does not have any kind of feedback, and it doesn't have any kind of clock signal. So all these things are basics, and these basics are applicable to all kind of combinational circuits. I told you in the earlier classes of combinational circuits introduction. And now let us try to understand the analysis of 2-bit comparator. Very important problems which we are going to see in today's class. At the end, I am going to teach 3 types of equations. These equations we may face in competitive exam point of view, and we may get questions from 2-bit and 3-bit, and we can say that n-bit comparator point of view. Let us try to understand comparator. We can say that this is what 2-bit comparator. 2-bit comparator. Sir, comparator is a combinational circuit, and now we have seen the 1-bit comparator. Let me try to explain what is 1-bit comparator. Sir, 1-bit comparator means there must be a 1 bit which is A, and this bit A is comparing with another bit B. So this is what happened. And now coming to 2-bit comparator, here also 2-bit comparator, what is happening is, this is 2-bit comparator. Here comparison between A and B only, but there are 2 bits in A and 2 bits in B. We can say that 2 bits are, I can call it as A0, and I can say that A1, and here also I want to call it as B0, and now here we can call it as B1. Now these 2 bits are comparing with these 2 bits. A0, A1 is comparing with B0 and then B1. So that is the reason we are calling it as 2-bit comparator. Here in 2-bit comparator we have 4 inputs which are A0, A1 and B0, B1. Now here A0, A1 is going to compare with B0 and then B1. So let us try to understand the analysis, how this comparison is going on. Sir, comparator is a combinational circuit. Whatever the combinational circuit we have learning, the things which we need to follow is, there are 5 defined steps, which are, we need to identify the number of inputs and number of outputs, and we need to know what is the characteristic equation, or we can say characteristic equation, or we can say Boolean equation, and logical expression we can also call, and we need to define the truth table, and we need to minimize the logical expression, and finally we need to construct one logical circuit. This is what the combinational circuits procedure we just follow even for 2-bit comparator. Sir, 2-bit comparator, the logical circuit, if we see here the logical circuit, I can say that this is 2-bit comparator, and now the inputs, as we seen here, A and B are the inputs, and outputs for comparator point of view, I told you in the previous lecture we have 3 types of outputs, X, Y and we can say Z. What is the X are here? X equal to, we can say A equal to B condition, and Y for A greater than B condition, and Z for A less than B condition. Sir, here A equal to B, A greater than B, A less than B. Here there are 2 inputs. When we learn about 1-bit comparator, we directly take A, B are the inputs directly. But coming to 2-bit comparator, there are 2 bits in each bit, which means here in A input we will be having A0 and A1, and B input we will be having B0 and B1. So these are the inputs, which means we have 4 inputs and 3 outputs. 4 inputs means we can say that here we may get 4 inputs means we may get 16 input combinations. 16 input combinations. This is what, sir, here I can write number of inputs are first point, number of inputs are we can say 4, and now number of outputs are we can say 3. So these are the 3 outputs. And now second point is drawing of truth table. The second point is truth table. Truth table I would like to draw here. Let us see. Sir, the inputs, when we are drawing truth table, we need to know inputs and outputs. Here inputs are we can say basically A0, A1, and now B0, B1. These are the inputs. What are the outputs are? We can say X, Y and Z. We can say Z. These 3 are the inputs. What is the X, sir? A equal to B condition. Y, sir? A greater than B condition. Z, sir? Here A less than B condition. These are the inputs and outputs. Let me try to draw a truth table so that we will understand completely how a 2-bit comparator is working properly. Sir, very important truth table. So if we can able to understand this truth table, from this particular truth table only we may get questions. Sir, here I want to write, here there are 4 inputs, which means 2 power n. Here inputs are 4, we can say that 2 power n, we can say 2 power 4, we may get 16 input combinations, which are 0, 0, 0, 1. We can say starting is 0. And now 0, 0, 0, 1. And now 0, 0, 1, 0. 0, 0, 1, 1. And now 0, 1, 0, 0. 0, 1, 0, 1. And now 0, 1, 1, 0. 0, 1, 1, 1. And now here 1, 0, 0, 0. 1, 0, 0, 1. 1, 0, 1, 0. 1, 0, 1, 1. And now 1, 1, 0, 0. Here 1, 1, 0, 1. And now here 1, 1, 1, 0. And finally 1, 1, 1, 1. These are the 16 combinations. Sir, let us try to understand. Here the comparison is between A0, A1 and then B0, B1. So we need to compare, and finally we need to draw how many number of equal A equal to B equal conditions, and how many number of A equal to A greater than B conditions, how many number of A less than B conditions. So let us try to draw. Please concentrate carefully so that we will understand. So the moment when we are comparing, what is the thing that we need to learn is, we just need to see the weightage of these 2 values, and we just need to see the weightage of these 2 values. Here this is what 0's place and this is 1's place. 0's place, 1's place. Likewise we can say that here 8421 code. We know that 8421 code. Here there are only 2 bits in A side and 2 bits in B side. We can say that this we can write as 1's place, 2's place. Here 1's place and we can say 2's place we can write. So here the first comparison is 0, 0, and then B0, B1 also 0, 0, which means A0, A1 weightage is 0, B0, B1 weightage is 0, so that both are equal. We can say A equal to B condition. Here there is no A greater than B and there is no A less than B condition. And now coming to C, here this is A equal to 0 and then A0, A1 both are 0. Here B0, B1, here combinedly we can say that here this weightage is 1 and then this weightage is 0, and now 0, 1 we can say that B is greater, so that we can say A is B condition is 0, and now A greater than condition 0 we can say A less than B condition is 1. And coming to this condition, here see the weightage, here this is 0, and now if you see the weightage, here 1's place 0 and 2's place 1, we can say that this weightage is 2. And now we can say here again B is greater, here this is 0 and now this is 0, again B equal to 1. And now according to 8421 code, I am comparing the weights. So please try to understand, this is what a basic truth table. I just want to compare. Here coming to A0, A1. Here this weight is 0 because A1 0, A0 0. And now here coming to this weight, we can say this 1's place is 1 and 2's place is 1. We can say entire weightage is 2 plus 1. We can say this weight is 3. So now here B also again 1. And now A 0 and B, A equal to B condition 0, A greater than B condition 0. And coming to third one, sir, here again the A1 is having a weight of 1 and B A0 is 0. We can say this weight is 1. And now coming to B0 and B1, here this weight is 0. Here B1's place 0 and B0's place is 0. So when we compare this one, A is 1 and then B is 0, which means A equal to B condition 0, A greater than B condition 1, and this is 0. And now here if we see A0, A1 and now B0, B1, both conditions are similar, 0, 1, 0, 1. So that we can say both weights are 1 and now here also weight 1, so that A equal to 1 condition, both are remaining are 0. And now this one, if you see here A0, A1 weightage is 1 and now here B0, B1 weightage is 2. If you see this one is at 2's place according to 8421 code, this one is at 2's place, so that this weight is 2. When we compare A and B, here B is greater, so that we need to take 1 here and both other things are zeros. And now sir, let us try to understand the third one. Here the weight is 1 and now here weight is 3. So again A less than B condition, 0, 0. And now coming to this one, sir, this weight is 2, here weight is 0, here 1 and both are zeros. And this one, here the weight is 2, here the weight is 1. And now this is 0. We can say A greater than 1 condition, B condition, here also 0. And now here both weights are 2, here 2 and then this weight is also 2. We can say equal condition, both remaining are 0. And coming to this one, here A is 2 weight and this weight is 3. So A less than B condition. And now here A not A1 weight is 3 and now B not B1 is weight is 0. So this one 1 and 0, 0. And coming to here, we can say that 1, 1 and 0, 1. We can say A is greater than 0, 0 here. 1, 1, 3, here 1, 0. We can say again A is greater, so 0, 0. And finally, if we see 1, 1, 1, 1, so here A equal to B condition. Sir, this is the truth table. You please try to understand this truth table. This is very, very simple. Very, very simple. According to 8421 code, there are 4 places. And if you want to write 1, so just you put 0, 0, 0, 1 here. If you want to write 2, 0, 0, 1, 0. If you want to write 3, you can add 2 plus 1. Here 0, 0, 1, 1. So likewise, if you can go, you will able to understand how to draw this truth table. This is very, very basic of digital. You need not to bother about how to learn how to draw this truth table. Very, very simple. You just follow 8421 code. And you can write up to 1 to 16. You can write any value, any binary value for any digit. Now, sir, the very, very important thing is this one, 1, 0, 0, 0, 0, 1. There are 16 A equal to B conditions. There are A greater than B conditions, A less than B conditions. Now the question is, how many number of A equal to B conditions? How many number of A greater than B conditions? How many number of A less than B conditions when we take 2-bit comparator? When we take 3-bit comparator? Friends, if you see 1-bit comparator, the truth table is 4 input combinations. 2-bit comparator, we have 16-bit input combinations. And if you can go for 3-bit comparator, 4-bit comparator, the truth table combinations may go up to 32-bit and then 64 input combinations, 128 input combinations, 252 input combinations, 516 input combinations, 1024 input combinations. The combinations will be increased. The moment when combinations are increasing, we don't know how to calculate how many number of A equal to B conditions out of this truth table. So we need a particular equation. By using those equations only, we can able to solve the question which is asked in gate or any PSU within a fraction of seconds. Let me try to teach a 3 simple equations to calculate these combinations, output possible combinations. Let us try to see the 3 equations. Sir, the basic questions we may get using bit comparator is, the first question they may ask this. The first question, how many number of input combinations, this is what one bit. To calculate the number of input combinations for whatever the bit comparator may come, the equation is y naught equal to, we can write this equation as 2 power n. This is what a very simple equation. And coming to the second equation is, how many number of equal conditions. So now the equation is y1 equal to 2 power n, a very simple equation. And now coming to third equation, how many number of lesser or greater than equation, which means a greater than b or a less than b conditions. So now to calculate this one, here y2 equal to 2 power n minus 2 power n divided by 2. This is what the third equation. Please note it down. Let us try to solve few problems over here so that we will understand. These are the very important equations. Sir, look at this truth table, and now if you can able to understand this truth table, let me try to explain. Here A equal to B, how many number of A equal to B conditions, sir? Here this is 1 and 2 and this is 3 and 4 conditions are there. Coming to A greater than B, here 1, 2, 3, 4, 5 and now 6 conditions are there. And coming to this one, here A less than B, 1, 2, 3, 4, 5, 6 conditions are there. Total A less than B 6 conditions, A greater than B 6 conditions, and now A equal to B 4 conditions. Total 16 combinations. Let us try to see by using these equations, is that calculation is possible or not. Sir, here y naught equal to 2 power n. What is the n, sir? Here n equal to 2-bit comparator. This is what 2-bit comparator. So n equal to 2. If this is 1-bit comparator, n equal to 1. If this is 1-bit comparator, we can say n equal to 1. Here 3-bit comparator, we can say n equal to 3. This is a simple logic. So 2 power 2, we can say that 2 power 4, we can say total 16 combinations are there. Sir, how many number of input combinations for 2-bit comparator? If the question is asked, what is the solutions are y naught equal to 2 power n, total 16 combinations. If you can calculate 0 to here, total 16 combinations are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and finally 16 combinations are there. And how many number of equal conditions? We can say y1 equal to 2, n equal to 2, we can say 2 square, total 4 equal conditions. Sir, we have already seen here A equal to B, 1, 2, 3, 4. So this is also satisfied. And now coming to how many number of equal, or we can say A greater than B, A less than B conditions. Here we know equation 2 power n equal to 2, and now minus 2 power 2, we can say that by 2. Here this is 16, the value of this 16, and now this will be 4 divided by 2. We can say that 12 by 2, finally 6. Finally 6 conditions. Sir, we have already calculated, counted, and now A greater than B are 6 conditions and A less than B are 6 conditions. This is the way of calculating the equations, number of possible equations, number of equal conditions, number of greater and lesser conditions. Thanks for watching. Please do subscribe.